What's up, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we are going to take a look at solving trig equations with infinite solutions. And this is going to be video number 3 in the series. So let's take a look at what we've got here. So we're going to find all solutions to the equation, both degrees and radians. And we know we got to find all solutions because it says so, which is a little bit different because sometimes we'll be told, hey, just go from 0 to 360. Or 0 to 2 pi. So if it doesn't specify that range of values, then we're going to find all the solutions. So with that said, we're going to take a look at one of them here by factoring. And so when we go to solve by factoring, the very first step you're going to want to do is analyze, how do I know that factoring would be the term or the technique that I would use? So if we look at all 3 terms that we're presented with here, we've got a constant term. We also have a linear term right here in 3 sine theta, and then we have a quadratic term right over here with 2 sine squared theta. So when you have a constant, a linear term, and a quadratic term, and your quadratic term and linear term are both in the same trig function, that's going to be kind of a visual clue, like, all right, factoring is going to be the technique that I use. So once we understand that that's how we're going to do it, then we're going to get everything set equal to 0. So notice how the 2 sine squared is positive. So I'm going to leave that term on the right side. So I'm going to work with that. So 2 sine squared theta, and then 3 sine theta is on the same side. So the other thing we have to do is write this in standard form. So 2 sine squared theta plus 3 sine theta. And then when you move the 1 over, that'll become plus 1. Now it doesn't matter where you put the equal 0. You can put it on the left side, the right side. And I'm going to add it here on the right. So there's our quadratic equation written in standard form. Now when we go to factor this, and factoring is a skill that just takes some time to really get down from your algebra 1 years, but when I look at this first term right here, 2 sine squared theta, there's only one way to factor 2 sine squared theta where both of your factors are positive, and that is simply with 2 sine theta and sine theta. So once we get 2 sine squared theta factored into 2 sine theta and sine theta, then I have to look at my constant term, which right here is 1. Now when I look at that 1, again, that's a prime number, so there's only 2 factors of that are positive, and there are 2 factors that are negative. So I could either use 1 and positive 1, or I could use negative 1 and negative 1. Either one of those will give me a product that is positive 1. How do I know which pair to use? Well, I'm glad you asked. So we're going to look here at our linear term, the plus 3 sine theta, and the sine of that kind of gives me a clue right there. And at this level, you should be okay with that. So that is going to factor into plus 1 and plus 1. So once we get the factors straight, now the rest of it is pretty straightforward because you'll know what to do from here. So you'll take each factor, 2 sine theta plus 1, set that equal to 0, and then take our other factor, sine theta plus 1 equal to 0. And you'll solve each one of them. So if I look at sine theta plus 1, that one's going to be a little bit quicker. So sine theta is going to be negative 1. And then I got to think to myself, all right, self, where on the unit circle is sine negative 1? So sine is my y value, and that's right down here at either 270 degrees or 3 pi's over 2. Now, if I were to write that with all solutions, because there's only one solution for this particular factor, so when I write that, I would say, all right, theta is going to be 270 plus, and then to get all the way back around to 270, I would have to add 360, so that's where we add our plus 360 n. We have to add that other piece, n is an element of the set of integers of z. Now, once I have that in degrees, then I'm going to write the same thing in radians. So theta would be 3 pi's over 2 plus, now 360 degrees in terms of radians is just 2 pi. But usually, in most cases, you'll see the n written next and then the pi written after that. If you write 2 pi n, that's totally cool. But don't forget to add the NEZ because you're indicating that n is of the set of integers, not some other set of numbers. So that takes care of the sine theta plus 1 factor, and that is one of our solutions. Now when we look at the other factor here, 2 sine theta plus 1, when you solve that equation for 0, you get sine theta is equal to 1/2. And don't forget the negative sign. So sine theta is negative 1/2. So now you have to think to yourself, well, where on the unit circle is sine negative? So thinking about those 2 pieces, you're going to have one that is down in quadrant 4 and one that is in quadrant number 3. And the value for these two spots, you're going to have 210 here in quadrant number 3. That's going to be one of your locations. And notice, you know, just kind of how that's 30 past the horizontal there. So 30 before the horizontal there would just be 330 degrees. So these are the two values right here that we have for sine theta being -1/2. So now notice how each one of these are separate, and they make kind of a V with the origin. So they make kind of an upside down V. And whenever you have that situation, that means you're going to have two distinct solutions for this one. So one of them is going to be theta will have the value 210. But to get back around to 210, we're going to have to add 360n and then NEZ. Now if you were to write that in radians, that would also just be theta equals, now 210 in radians is 7 pi's over 6. So, and then again, 2n pi and then NEZ. So that takes care of this particular solution right there. So that's that component of it. So that's our first one. Now our other solution is 330. We'll have to write that separately for that one. So we would have theta would be 330 plus 360n, and then n is an element of the set of integers. And then same thing, if we were to write that using radians, then 330 in radians is going to be 11 pi's over 6 plus, and then 2n pi, where n is an element of the set of integers. So that is how you solve this particular type of problem, by factoring. So you're going to end up with one set of solutions coming from your first factor of 2 sine theta plus 1. You'll get two values there, 210 and 330. And then you'll have another set of values coming from your other factor of sine theta being -1. All right, that's it for this video. Thank you guys for watching. Make it a great day as always, because there's no good reason not to. Get out there and show a bit of little love and gratitude towards somebody around you. And I'll catch up with you soon. Peace out.